Hi, everybody. I'm here to talk about Celestial Jukebox. And there are many reasons that I personally enjoy the lesson, but I find it very useful. So this is how I'm going to talk about the layout of today's short presentation, why I chose it or why anybody would choose it for physics. I'll overview the lesson a little bit, walk through it. I'll give you a few notes of things that worked and didn't work and what resultant analytics you can use. So I found that this particular lesson had inquiry. It was inquiry based, in my opinion, because you can use it without teaching Kepler's third law first. In other words, you don't have to say, okay, today we're going to talk about Kepler's third law, and this is the equation, and this is the math of it. The kids can go straight into this VFT, right? They could go right into it and discover the law using this. And that makes it more exciting. It allows for a deeper learning whenever there's this inquiry-based idea. Another reason is that the adaptive feedback facilitates the inquiry. The visuals are very creative, and the mathematical depictions, the graphs, the real-time creation of graphs, I thought were amazing. So for the teacher, the instructional objectives are there on the website, so you can just click and have all of these things available to you. The standards are available to us also, the NGSS, etc. So all of these forms are available, which I find very useful that it's ready to go. I thought the student and teacher guides were also very well done. And the student guide could be used after. It can also be used after the lesson. In other words, after they finish, they could go and do this almost like a little review of what they learned during the lesson. The creative part of it was that it made the connection of as the planets are orbiting around a star and they're transiting, it made that connection to sound, so that it kind of occupies all the senses. So the kids can hear the sound and also see the orbits of the planets. And then little by little, they're led to collect data, actual mathematical data. As they're going through the little tasks, for example, here, this particular one, you had the star, which is this yellow, and you don't really see the planet, but the planets would go around and around like this. And as they were going around, as soon as they were at the transit location, the thing would beep. And you would hear, you kind of quote unquote hear the frequency of the beep. And then you were told, okay, now change the distance and see what happens. So if the student didn't know a definition, there's a yellow, certain terms are highlighted in yellow and they could click and see what the definition is. And if at some point when you completed the task, you were asked a question, and for example here, the furthest the test object is from the star, and then you have like a multiple choice thing, the further apart the beats occur. And if you didn't get it right, you get your adaptive feedback. So to lead you to try to, on your own, come up with the correct answer. If you did get it right, you get a little bit of positive feedback right here. So another highlight, I really thought this helps a lot with the inquiry, in that, okay, so you didn't remember, a student didn't remember what's the orbital period. They click and here's your definition. So it saves time to the student to then have to look up the term. that could lead to frustration if you have to spend more time trying to go look up the definitions. It increases the time of the project itself. So this saves time. And here, it would, if whoever doesn't need to see it doesn't have to click on it. So those students can just continue moving to the next thing. As a little bonus and to make it fun, kids get these little coins to use in the jukebox. This is why it's called Celestial Jukebox. And I absolutely loved the graphs and the math, and I'll show you why. So, so this is a still shot on the actual Celestial Jukebox screen. You see the planet going around and around and around like this. As the planet is doing this orbiting, the graph is created in real time. So first one, the second one, the third one, in real time as these things are happening. And that helps the kids visualize really, again, with all the senses, the sound, looking at the planet and looking at the graph of intensity versus time. And it has not just this one, but many of this type of elements in this lesson. And again, here you go with your multiple choice. If you get it right, you move on to the next task. The mathematical aspect I thought was very, very creative. So normally when I have data and I want the kids to graph data, I'll have them go into Google Sheets or Excel, etc. And they will graph the data. And we're talking about high school kids now. They graph the data, and then they would have seen like this dot, this dot, this dot, that dot, right? The data points. It's distance versus period. So they would kind of have to have an idea of what the equation is that they're looking to graph. And thus they will probably have to look up Kepler's third law, you know, to see what the idea would be, what would be that relationship. So this one it had a very interesting way of doing it. I don't know if you can see the bottom of my slide, because in my view, I have like the pictures of everybody in front, but behind our pictures, it has like a little, it has the period and a number, the exponent number, right? And so same here, it has the period there, it's got like the distance. And you can go in here and change the exponent. And as you're changing the exponent, the curve changes. So you can see if you put like 1 and 1, and then you get your straight line, clearly that's not the right shape to cover, to describe this data. So then the kids have the opportunity to change these numbers, these exponents. And as they're changing the exponents, they can visually see which of these curves match the best. It's like a beginner's way of looking at matching your data, finding the best curve fit of your data. And they do trial and error. They try one, it doesn't work. They try the other, it doesn't work. Sorry about that. And so forth. So I found that to be very, very creative for them. So they adjust these numbers, and they can see the curve changing right away. So another nice element was the math board, and it doesn't have only just one, it has several math boards. So for example, here, if they were asked to find, this was after they had already discovered the relationship. See, it says use Kepler's third law to determine the distance. But at this point, they had already discovered the relationship, I should say. It was not given by the teacher, it was discovered by the students. And that's what makes it special. But the math board, in case the student doesn't remember what the equation was, you get a hint that it's proportional to the third, the cubed root of p squared. So D is proportional to the cube root of P squared, and it gives them the equation there to use in case they forgot what the formula was. So I know that many of us are working remotely, so this one is actually very, very student friendly in a situation where, you know, the student has to be remote, you know, working by themselves, not in the classroom, so that this continually gives them guidance and feedback and adaptive feedback. So to recap briefly, things that I found working, I love the adaptive feedback. The terms are defined, so it's easy for the kids, it's at their fingertips. The graphs were generated in real time, and they're able to, for example, change the exponents to see the curve fit. The math board's very, very well done, visually strong. And things that I find could be improved is the beginning of the actual VFT. It went a little bit too long at the start, like the beginning concepts that one gets quickly. One should be able to move on to the next part a little bit faster, so that you could get to the points where you need to think, use your critical thinking a little bit more. So I'd like the beginning, I would have, if I ever had the opportunity to trim it, I would trim the beginning a little bit. And I would like to have the opportunity to toggle back and forth. For example, if you were at the math board, but you wanted to go back and look at the curve, you don't have that ability. So I think that it would be useful for a student to be able to go backwards and forward. And like you're reading a book, you scroll forward in the pages and backward in the pages. So that's the one thing I would have liked to see. So what are some benefits? Well, it strengthens the student learning. It's by being an inquiry-based type of lesson. It increases the visualization. The student has the ability to analyze graphs better. The model is being used, and the student discovers the model themselves. It increases motivation because of the fact that the student is able to accomplish this. It's well done, and to the level of the students that they're able to accomplish it. Analytics, as Diane and Audrey mentioned before, you already saw the types of analytics that are available for a teacher to use. And to recap, it's an adaptive lesson, wonderful lesson, uses the models, it's the discovery, Kepler's third law, increases motivation, standards-based, wonderful lesson. That's all I had to say.
2 thumbs up from Helen.
Yep.